Okay, so you guys have probably seen questions like this on your assignments, and it's kind of hard to, I'll be honest, it's kind of hard to read with the black ink. So let me go ahead and scroll in. But what it's asking you is to write a rule to describe each transformation. Okay, so what we have here is we have an original shape, and then somehow this shape has been moved. Okay, so you see, it's really hard to see, but you see how the little letters with the little like apostrophe? You see those guys versus just regular D, and then there's the D apostrophe. Regular D is the original D. So let's go ahead and trace the original shape. I'll trace it so you guys can see it better. Okay, so there's my original quadrilateral, technical term. Okay, what's happened is all four of these points, this technically isn't a function, it's just kind of a shape, but it has been transformed. Somehow these points, these original 4 points right here, what is it? B, E something, okay, they have been moved. Okay, so all we have to do, you guys, is identify one of those points and then say how it moved. Okay, so the easiest one for me to see is this original D point right there. And the moved, transformed D point right there. Okay, so all we got to identify is how it's moved. It went how many? Up one or down one? Up one. Okay, to the right one or to the left one? This is going to help with our rights and lefts. To the left one. I'm actually really bad with my left and rights.
Me too.
To the left one.
You do the thing with your L's?
Yeah, but I'm still bad at it. Okay, and that's literally all it's asking us to do there, is identify the original point, the ones without the parenthesis or the apostrophe, okay, and then identify how it's been moved. Because if this D went here to here, that means that that point also went up one to the left one, up one, left one, up one, left one. Do we see? You just take each point technically, and that's how it moved. Pretty easy. Okay, let's do it again. Okay, so now look at your symbols. Look at your symbols here, the letters.
Wait, is that all we do? We just up one, left one? And do that
You're just writing how it moved. So this would be your answer. Up one, left one, right there.
I thought we'd have to write it equate, and I was scared.
Nope, because it's technically not a function, it's just a shape. Okay, so tell me, you guys, based on my rule, which one is the original shape? The one on top or the one on bottom?
Bottom.
Top.
The one on top, right? Because our letters don't have the apostrophe,
Oh, yeah.
right? This guy is our original. I'll trace him. He's our original. So now we just need to identify how this V went from here to here, how that U went from there to there, and W from there to there. So which point do you want to focus on? We just need to focus on one. You? Sure. Let's focus on you. Okay, so let's just count to our next point. From U to U. So I need to go down 1, 2, 3, 4, 5, 6. Okay. I'm about to move you guys. Thank you. Okay, so we went down 6. And then we need to go to the right 1, 2, 3, 4, 5, 6. We went down 6. And to the right 6.
Oh, right.
And we know if we took that U down 6 and to the right 6, we would have to do the same thing with V and W. Down 6 and right 6. Okay. That fancy word transformed, it just means moved. That's all it means, is moved.
We're just moving things.
Okay, so let's try it again. Pretty simple, right? Number 3. Which one is my original shape? The top one or the bottom one? Top one. Nice. It doesn't have the apostrophes on them. Okay, so here's my original. No apostrophes on my letters. Which point do you guys want to grab?
S.
S? Sure. Okay, so we'll look at S. So that needs to go from that S to S apostrophe. Okay, so in order to move there, I'm going down 1, 2, 3, 4, 5. Do I have to move to the right or left any? Nope, I just moved down 5. So that means every single point moved down 5 as well. Down 5. Okay. Awesome. One more. Okay, which one's my original? The top one, right. No apostrophes on that guy. Okay, which one do you want to grab and focus on?
Q.
Q? Sure. Okay, let's grab Q. Okay, so I'm going to go 1, 2, 3, 4 down to get to my next Q. So we went down 4. Okay, then we're going to go to the right. 1, 2, 3, 4. Down 4, to the right 4. Okay. Awesome job, you guys. Pretty simple. You can take a shape and see how it's been transformed. Or on your assignment, if it like gave you the shape and told you how to move it, you'd know where to move the shape. Left 2, up 1. Yeah? Okay, awesome, because you're going to have to do that on your test. Now, for numbers 5 and 6, it's saying find the coordinates of the vertices of each figure after the given transformation. What in the heck does that mean? Okay, so here's what I want you to do. It gives us these vertices. Okay, these are our x's. The tops are our x. The bottoms are our y. Yep.
HY.
So it's kind of written as a coordinate point just a little differently. Okay, and what we're going to do is we are going to write new coordinate points or vertices based on what it tells us, how it's moving. Okay, so let's read how it's moving. This is moving 1 unit right and 6 units down. Okay, well tell me, let's draw a little graph right here. We know this is my x-axis and this is my y, which means left and right has to do with which axis? The x-axis. Okay, so right is going to affect my x's. Okay. Up and down has to do with which axis? The y. So that's going to affect those guys.
So that means it'd be probably negative.
Okay, so here's all we got to do. If it wants us to take 1 unit to the right, what is -3? Now think of on a number line. What's one number to the right of -3 on a number line?
-4.
Very close. Let's look at a number line right here. Okay, so if I'm at -3, -2, -1, 0, -4, what's 1 unit to the right? -2. Okay, so that first little spot turns into -2. We took it 1 unit to the right. Okay, lucky for us, the next one's the same exact thing, so 1 unit to the right of -3 is still -2. Okay, what's 1 unit to the right from -1? 0. Good job. Okay, there's our new vertices, our x coordinates. Okay, awesome. Now let's do our 6 units down. Okay, think of a y-axis. If I'm sitting at +1 and it wants us to take it 6 units down, where am I going to land, Jameson? -5. Love it. Okay, so that +1, we took 6 units down, became -5. What about +5? If I'm at +5, down 6 units. -1. Okay, same thing there as well. -1, -1. And there's our answer. Okay, so the top guys were affected by left and right. Bottom guys were affected up and down. Okay, so let's do the same thing for number 6. Okay, so we're going to write a new vertices right here. So you can go ahead and just give yourself your little brackets. We just need to figure out what numbers are going to be inside based on how we're moving them. Okay, so my transformations or translation, another way of saying it, 2 units to the left. We know those guys affect my x's. Left and right affects the top guys. And up and down affect my y's. Okay, so let's figure out how these numbers are being affected. So we're going to take the top ones first. We're going to move each one of those guys 2 units to the left. Think of on a number line again. If I'm sitting at positive 3 and I'm taking it, in fact, if you want to draw it, I like drawing it. 0, 1, 2, 3. Okay, so if I'm sitting at 3 and I need to take it 2 units to the left, 1, 2, where did I just land?
Positive 1.
Positive 1. Okay, same thing. Positive 3 again, which means put us at positive 1. What about 5? Okay, so now I'm at 5. 2 units to the left would put me at positive 3. Beautiful. So that's how it's been shifted to the left. What about 1 unit up? If I'm sitting at negative 3 on my y-axis and I'm going up 1, where does that put me? Ooh, very close. That would be down 1.
Positive 4.
Ooh, negative 3, I'm going up 1.
Positive 3.
Negative 4. Wait.
Negative 2.
Negative 2, right? Negative 2 would be up 1. Negative 4 would be down 1. So it wants us to go up 1, which would put us at negative 2. 0. 0, 0. Great job, Lily.
Yeah, I don't understand.
We're coming to you.
Okay, and there we go. Oh, shoot. Christine. I am. Yes.
It's a call. He's getting a rush for teaching too much harsh
Okay.
Like who's being arrested?
Is Campbell for teaching too much harsh math?
Oh, I see. I see.
Mm-hmm.
So at night, as a day.
I would tell her exactly that, and I can reiterate it too, that, you know, based on her IEP and the services that she wants, co-taught ELA is where she needs the most support. Yeah, so, yep. They do, yep, they do.
No.
No.
I hope it goes off in this class.
Okay, perfect. Okay, thanks Christine, yep, bye.
Okay. Nice job, you guys. So, that's how we just found basically new coordinate points. It's almost like you took a graph, but you didn't even need it, and you moved it somehow. Okay, so let's look now at our next examples. Okay, so this is the opposite of what we had to do for our starter. It says explain in words how the function has been transformed. Okay, so remind me, inside my parentheses means what? It's either left or right or up or down. Inside parentheses.
Right.
Ooh, nice. It's left or right. Okay. With plus, look on your starter if you need another hint. With plus on the inside, are we moving to the left or right?
Left.
Left. Nice job. Okay, so. Yep. Pretty simple, right? Okay, so we can go left 2. That's what it's telling us right here. Left 2. Okay, and what about on the outside? We know it's up or down on the outside. Based on this minus 4, are we moving up 4 or down 4?
Down.
Down 4. Good job. Okay, and there we go. That's all we have to do for 7 and 8. Identify how it's being moved in words.
The only word I have.
Did you put those questions in yourself?
Yes, I did. Okay, now, absolute value. Tell me, with this negative 1, I'm not even going to give you a hint here. Am I moving up 1, down 1, left 1, right 1? What is it, Lily?
You're doing right and right.
Nice, beautiful. Yes, inside is always left and right, and minus means to the right. So we're moving right 1. What about this plus 5 on the outside? How is that being moved? It's either up or down 5. Which one is it?
Down. Up.
It's up 5, right? On the outside, just think plus, up, down, minus. So up 5. Beautiful. Okay, so that's another thing you're gonna have to do on your test is look at a function and identify how it's being moved. Explain. Okay, so turn your paper over. Okay, so this is the biggest part of our test, and it is graphing these functions. So it says graph the transformed functions. Okay, so let's go ahead and identify what our parent function looked like to even begin with. So this guy started out as just an x squared, just a quadratic. There's our parent function. Nothing's added there. Okay, and if we remember our parent function points, okay, we've drawn these tables like quite a few times. -1, +1, 0, 0, +1, +1. Okay, and all we did there was choose numbers to plug in for x and solved and got our y's. Okay, so now what we can do is we can take our parent function points, put them on our graph. -1, +1, 0, 0, +1, +1. Okay, but don't connect them yet because that's not the function it's asking us to actually graph. It's asking us to graph this function. Okay, so let's go ahead and identify how has that function been moved based on what's been added here. Raise your hand and tell me one transformation. Left, right, up, down. How many? Who thinks they have one?
Oh.
Donovan?
Down one,
Ooh,
up one.
ooh, not quite. I see a 1 here, so I see where you're looking. But remember, inside my parentheses is left and right, always. So is this going to be left 1 or right 1?
Yeah.
Good job. Okay,
Right
so
one.
right there is
Yeah, I'll write 1.
left 1. Okay, what's my other transformation? What else has been added? And how are we going to move these points? Jameson, down 3. Beautiful. Okay, so take that function, identify what's been added, our transformations, and now all we got to do is take each one of these 3 points, move them to the left 1 and down 3. Okay, so let's go ahead and do that. Left 1, booyah, right there, and down 3. 1, 2, 3. Okay, and you're going to do that for every single point. Now I'm going to start with this middle point, left 1, boom, down 3, 1, 2, 3. Okay, and my last point, left 1, down 1, 2, 3. Okay, still the same shape, just moved it.
That's right, not left.
Okay. Alrighty, number 10. We have a transformation here that we have not talked about yet, but it's not too complicated of one. Okay, so let's go ahead and just do what we did to begin number 9. Let's go ahead and identify the parent function. This time it starts with y equals. Okay, our original function was just our absolute value function. Easy peasy. Yeah.
Is that the same thing as F parentheses X?
Yeah, great question, Donovan. Y is the same thing as f of x. Yep, means the exact same thing. Great question. Okay, so our original function, just absolute value of x. We remember our parent function points. If I plug in a -1, I get a +1. If I plug in a 0, I also get a 0. +1, I get a +1. So these are actually the same parent function points as a quadratic.
What is here and X?
That is an x. Yeah, that kind of looked like an a, huh? Okay, so now we can take these parent function points, put them on our graph. -1, 1, 0, 0, 1, 1. Okay, do not connect them yet. Okay, because here is our first transformation that we need to talk about. Okay, brand new transformation, and it has to do with this guy right there. Okay, when we see a negative on the out front, this means we're going to flip it. Okay, so it started out as a V, right? Absolute value. Opening up, now what's it going to do?
Flip.
Yep, it's going to flip. Okay, so let's go ahead and take these guys because it would. We'll just do a little outline, a little imagine that connected right there. But flipping it down now goes like this. Okay, it's been flipped. Another little imaginary one. It's been flipped upside down. But that's not the only transformation. So we know the arrows are going to point down now because it's been flipped. But what are my other transformations based on these guys? Raise your hand if you think you know how at least one of them is being moved. Left or right, up and down. What do you think? What do you think? Inside my parentheses or absolute values, left and right.
Left,
Down. No,
Right.
left.
Right?
Right.
Because
Left, you got it. Sometimes even I have to check.
flipped.
Left 2. Okay, so we already flipped
Oh,
it.
it's flipped. Oh.
So it's flipped right here. That's just like putting it upside down.
Oh.
Okay, upside down. We already made the upside down. But then it's being taken to the left 2. And what about that guy?
down one.
Down 1. Good job.
Are you Xing out the whole worksheet?
Nope. In fact, go ahead and just erase that one from your imagination. It looks like this. It's being flipped over.
Yeah, I would just flip it around.
Where?
Okay, so now we're taking these 3 points. Boom, boom, boom. Because we flipped them. We're taking them to the left 2 and down 1. So let's go with this point first. Left 2, 1, 2, down 1. Boom. There we go. Now this point, left 2, boom, boom, down 1. There we go. Now this point, left 2, down 1. And now there is our finished transformed function. It's been turned upside down. It's been flipped. That's why the arrows are now pointing down. And it moved to the left 2 and down 1. Okay, there is one more function, parent function, that we need to talk about really, really quick, okay? So in this blank space on the back of your paper, go ahead, let's do this guy right here. We'll call this example 11. Okay, and we'll go fast, don't worry. Okay, so this parent function looks like that. That is y equals the square root of x.
How do you what?
The square root of x.
What? How do you do that?
We're gonna show you. Okay, so
No.
draw yourself a little graph. Doesn't have to be perfect by all means. Definitely not. Mine are never perfect. Okay, so here's what we were doing, you guys. Remember when we graphed these parent functions, we found the points, started with a little table, chose numbers to plug in for x, and then when we plugged it in, what did we get out for y? Okay, well, here's the thing. Here's the tricky thing with this guy. I want to choose numbers that are actually perfect squares that I could square root. For example, is there a square root of 0?
No.
Yeah.
What is the square root of 0?
0.
0. Is there a square root of 1?
Yeah.
No.
No, there's 2.
Yeah.
What is the square root of 1?
1.
It's 1.
Oh.
Square root of 0 is 0 because 0 times 0 is 0. Square root of 1, in fact, let's write these down. Square root of 0 equals 0. Square root of 1 equals 1 because 1 times 1 is 1. Now, do I want to choose 2? Is there a perfect square of 2? Let's check.
Yeah.
Let's
Four,
check. Ooh, ooh. Square root of 2? Oh, definitely not.
right? Oh, never mind.
Is there a square root of 3? Nope.
What about 5?
Is there a square root of 4?
Yes.
What's the square root of 4?
2.
2.
2, because 2 times 2 is 4. Okay. So I'm actually going to choose as my 3 numbers 0, 1, and 4. We know that the square root of 1 is 1, the square root of 4 was 2. So these ones are way different than the other ones we were plugging in. Why didn't I plug in a negative though? Because watch what happens when I try to plug in a negative in a square root. Square root, can everybody see this? Let's try -1. Is that possible? No, there's no such thing as a negative number inside a square root. That can never happen in math. Okay, so that's why on these guys I only have positive numbers But I chose positive numbers that would actually work, that would give us a nice, pretty number. Okay, so let's go ahead and put these coordinate points on our graph. 0, 0. We know where that is. 0, 0. We know where 1, 1 is. Up 1, over 1. Okay, but then our next point is 4, comma 2. So find 4 on your x. 1, 2, 3, 4. And then go up 2. 1, 2. Okay.
Oh, that's what that is?
Why didn't I go below the x-axis, you guys? Because what did I just show you on the calculator? Does
There were no
negatives ever work?
No.
Nope. So guess what? They'll never go into that. Okay? They might move based on the transformation, but our parent function point will never go into the negatives. Okay? So that's another parent function that we needed to talk about.